Volcanoes are fascinating natural phenomena that have captivated humans for centuries. However, despite the countless studies and research conducted on these powerful geological formations, there are still many misconceptions and myths surrounding them. In this light, let's bust some of the most common volcano myths. Welcome to our channel where we bring you the latest news, discoveries, and innovations from the world of science. Join us as we explore the fascinating and often misunderstood world of volcanoes and separate fact from fiction. Volcanoes are dangerous only when they erupt. It's easy to assume that a volcano is only dangerous when it's actively erupting and spewing lava. However, this couldn't be further from the truth. In fact, volcanic eruptions are relatively rare events, and most of the danger associated with volcanoes occurs in the aftermath of an eruption. Volcanic eruptions can trigger landslides, mudslides, and volcanic debris flows that can travel at high speeds and bury entire villages in seconds. Additionally, volcanic ash can cause respiratory problems and other health issues, especially for those with pre-existing respiratory conditions. Furthermore, the toxic gases released during volcanic eruptions can pose a serious threat to human health and the environment. Even dormant volcanoes can pose a risk, as they may erupt suddenly without warning, catching people off guard. Therefore, it's crucial to take all volcanic activity seriously and follow safety guidelines provided by local authorities. Volcanoes only occur on land. This is another common misconception about volcanoes that many people hold. They are often thought to occur only on land, but this is not the case. In fact, volcanoes can also occur in the ocean. Underwater volcanoes are quite common and occur when magma rises from the Earth's mantle and creates a new landmass on the ocean floor. These volcanoes can be just as dangerous as their terrestrial counterparts, as they can cause significant damage to marine ecosystems and trigger tsunamis. One of the largest volcanic eruptions in recorded history occurred in 1815, when Mount Tambora, located in Indonesia, erupted violently. The eruption was so powerful that it caused massive devastation and loss of life, leading to the year without summer in 1816. Volcanic eruptions are always accompanied by earthquakes. Although volcanic eruptions are often preceded by seismic activity, it's not always the case. Some volcanoes erupt without any prior earthquakes, making it difficult to predict their eruptions. In fact, earthquake activity may even decrease before a volcanic eruption as the magma ascends into the crust and pressure and pore fluid conditions change. For example, the 1980 eruption of Mount St. Helens in Washington state did not have any significant earthquakes preceding it. On the other hand, some areas may experience frequent earthquakes due to volcanic unrest, but these events may not necessarily lead to an eruption. Therefore, while earthquake activity can be an indicator of volcanic unrest, it's not a foolproof method for predicting eruptions. Scientists constantly monitor seismic activity in volcanic regions to identify patterns and potential precursors to eruptions. Advanced instruments such as seismographs can detect even the smallest tremors, providing valuable data for eruption forecasts. By analyzing the frequency, intensity, and timing of earthquakes, geologists can assess the likelihood of an eruption and issue timely warnings to local populations. Volcanoes always look like Mount Vesuvius or Mount Fuji. Not all volcanoes have the same shape or appearance. In fact, volcanoes can come in a variety of shapes and sizes depending on factors such as the type of magma, eruption style, and tectonic setting. Shield volcanoes, for example, are broad and gently sloping and are created by fluid basaltic magma. Composite volcanoes, on the other hand, are tall and conical and are formed by more viscous and explosive magma. Cinder cone volcanoes are small and steep and are created by pyroclastic material. Each type of volcano has a unique set of characteristics and can produce different types of eruptions. Therefore, it's incorrect to assume that all volcanoes look like Mount Vesuvius or Mount Fuji. Volcanoes only form on the Earth. Our planet is not the only one with volcanoes. In fact, volcanoes can form on other planets and moons as well. For example, Mars is believed to have had extensive volcanic activity in the past, and present-day Mars is home to Olympus Mons, the tallest mountain in the solar system. This massive shield volcano is 3 times the height of Mount Everest. Io, a moon of Jupiter, is also volcanically active with more than 400 active volcanoes that reach heights of up to 300 meters. The heat from Io's interior is generated by the tidal flexing caused by Jupiter's gravitational pull, which creates enough heat to melt rock and cause eruptions. Therefore, while Earth's volcanoes are fascinating and unique, they are not the only volcanoes in the universe. Magma always flows downhill. Despite what many people believe, magma doesn't always flow downhill. In fact, the direction of magma flow is determined by several factors, including the topography of the land, the viscosity of the magma, and the amount of gas and pressure. For example, in mountainous regions, magma can flow upslope. In such cases, the force of gravity pulling the magma downslope is overcome by the topography of the land. Additionally, less dense magma can also flow uphill. This phenomenon is known as reverse gravity flow, and occurs when the buoyant force caused by the low density of the magma is stronger than the gravitational force pulling it down. Furthermore, the amount of gas dissolved in the magma can also affect its flow direction. When magma contains a high amount of gas, it becomes more buoyant and can flow in unexpected directions. Therefore, it's inaccurate to assume that magma always flows downhill. Volcanoes emit poisonous gases. While it's true that volcanoes can emit various gases including carbon dioxide, sulfur dioxide, and hydrogen sulfide, it's important to note that these gases are not necessarily poisonous. The level of toxicity depends on the concentration of each gas and the duration of exposure. For example, carbon dioxide is a common volcanic gas that can pose a significant threat to human health if it reaches high concentrations. However, carbon dioxide is also the primary component of the Earth's atmosphere and is essential for human survival. Similarly, sulfur dioxide and hydrogen sulfide can cause respiratory problems if inhaled in large amounts, but they are also naturally occurring gases in the atmosphere. Therefore, it's not accurate to make a blanket statement that volcanoes emit poisonous gases. Instead, it's more appropriate to say that volcanoes emit gases that can be harmful to human health if they reach certain concentrations. All volcanic eruptions are catastrophic. As mentioned earlier, volcanic eruptions can have devastating consequences, but not all eruptions are catastrophic. In fact, some eruptions are relatively small and pose minimal threat to human life. For example, Strombolian eruptions are small, short-lived eruptions that produce lava flows, similar to those seen at Stromboli Volcano in Italy. Volcanian eruptions are slightly larger and produce more explosive and sustained eruptions with moderate ash and gas emissions. At its most basic level, lava fountains are small, localized eruptions that occur at vents or fissures in the Earth's surface. They are relatively harmless and pose little threat to human life, unless they contain high levels of gas and pressure, which can cause them to become more explosive. Therefore, it's incorrect to assume that all volcanic eruptions are catastrophic. Volcanoes are only found at plate boundaries. While it's true that many volcanoes are located along plate boundaries, they are not exclusively found in these areas. In fact, volcanoes can occur anywhere magma can reach the Earth's surface. For example, the Hawaiian Islands were formed by a hotspot, a plume of hot magma that rises from deep within the Earth's mantle. As the Pacific plate moves over the hotspot, magma erupts through the crust, creating new land masses. Additionally, some volcanoes are located far from plate boundaries, such as Mount Kilimanjaro in Tanzania and Mount Kenya in Kenya. These volcanoes are thought to have formed when the surrounding land masses began to rift apart, allowing magma to rise to the surface. Therefore, while plate boundaries are common locations for volcanic activity, volcanoes can be found in other areas as well. Volcanoes can be predicted with accuracy. Despite advances in technology and scientific understanding, predicting volcanic eruptions remains a challenging task. Although scientists can identify signs of volcanic unrest and estimate the likelihood of an eruption, they cannot determine the exact time and magnitude of an eruption. Factors such as the complexity of volcanic systems, the rarity of eruptions, and the difficulty of monitoring all contribute to the uncertainty surrounding volcanic predictions. For example, Mount Pinatubo in the Philippines had shown signs of unrest for years before its massive eruption in 1991. However, scientists were unable to predict the exact timing of the eruption, which caught many people off guard. Therefore, while scientists continue to work towards improving volcanic prediction techniques, it's important to recognize the limitations of current technology and scientific knowledge. In conclusion, volcanoes are fascinating geological formations that have captured the attention of humans for centuries. However, there are many misconceptions and myths surrounding these powerful natural phenomena. By separating fact from fiction, we can gain a deeper appreciation for the power and beauty of volcanoes, while also understanding the risks they pose. If you enjoyed this video and want to learn more about volcanoes and other fascinating topics, subscribe to our channel and stay updated on our latest content. Thank you for watching, and we'll see you in the next video.